Polynomials and factorization exercise 2.2 part 2. Verify whether the values of x given in each case are the zeros of the polynomials or not. So first bit, p of x equal to 2x plus 1. This is the given polynomial. X equal to minus 1 by 2. This is the value of x given. So what should we do now? We have to find out whether this particular value of x is the zero of the polynomial or not. So in order to find that out, what is the meaning of zero of the polynomial? If for this value of x, the value of p of x is 0, then we call that particular value as the zero of the polynomial. So p of x equal to 2x plus 1 here. So we have to calculate p of minus 1 by 2. P of minus 1 by 2 equal to, we have to substitute minus 1 by 2 in the place of x in the given polynomial. So p of minus 1 by 2 equal to p of 2 into minus 1 by 2 plus 1. So 2 cancelled, minus 1 plus 1 equal to 0. So p of minus 1 by 2 equal to 0. So if this is 0, then we can call minus 1 by 2 as the zero of the polynomial. So the given value of x is the zero of the polynomial. So it is a yes. Second bit, p of x equal to 5x minus pi, x equal to minus 3 by 2. So let's substitute minus 3 by 2 in place of x in the given polynomial. So we have to find p of minus 3 by 2, which is equal to 5 into minus 3 by 2 minus pi, which is equal to minus 15 by 2 minus pi. But this value is not equal to 0. So as p of minus 3 by 2 is not equal to 0, minus 3 by 2 is not the zero of the polynomial. So this is a no. Third bit, p of x equal to x square minus 1, x equal to plus or minus 1. Here they have given two values for x. So we have to find the value of p of x for both x equal to plus 1 and x equal to minus 1. So first let us calculate p of 1. That is p of plus 1. P of x equal to x square minus 1. P of 1 equal to 1 square minus 1. So 1 minus 1 is 0. So p of 1 is 0. Let us calculate p of minus 1. Okay. Minus 1 whole square minus 1. So that is also equal to 1 minus 1, which is equal to 0. As p of 1 equal to 0 and p of minus 1 is also equal to 0. Plus 1 and minus 1 are the zeros of the polynomial. So this is a yes again. Fourth bit, p of x equal to x minus 1 into x plus 2. X equal to minus 1 minus 2. So let us write p of x first, x minus 1 into x plus 2. P of minus 1 equal to minus 1 into minus 1 plus 2. So minus 2 into plus 1 is minus 2, but this value is not equal to 0. So p of minus 2 minus 1 into minus 2 plus 2 equal to minus 3 into 0, which is 0. So here we can see that p of minus 1 is not equal to 0 and p of minus 2 is equal to 0. So as p of minus 1 is not equal to 0, minus 1 is not the zero of the polynomial. So it is a no. But for p of minus 2, it is equal to 0. So minus 2 is a zero of the polynomial. So this is a yes. So for minus 1 it is a no, and for minus 2 it is yes. Fifth bit, p of y equal to y square, y equal to 0. So p of 0 equal to 0 square, which is also 0. So as p of 0 is equal to 0, 0 is the, this value 0 is the zero of the polynomial. So it is a yes. Sixth bit, p of x equal to ax plus b, x equal to minus b by a. So let's substitute minus b by a in the place of x in the given polynomial. P of minus b by a equal to a into minus b by a plus b. A and a cancelled. Minus b plus b is 0. So p of minus b by a is 0. So minus b by a is the zero of the polynomial. So this is again yes. Seventh bit, f of x equal to 3x square minus 1. X equal to minus 1 by root 3. X equal to 2 by root 3. Here two values are given. So we have to find for each value what the value of f of x is. So f of x equal to 3x square minus 1 f of minus 1 by root 3 equal to 3 into minus 1 by root 3 whole square minus 1. So 3 into minus 1 by root 3 whole square is 1 by 3. So 3 into 1 by 3 minus 1 equal to 1 minus 1 0. So for minus 1 by root 3 f of minus 1 by root 3 is 0. So we can call minus 1 by root 3 as a 0 of the polynomial. So it is a yes for minus 1 by root 3. So again let us calculate for 2 by root 3. F of x equal to 3x square minus 1. So f of 2 by root 3 equal to 3 into 2 by root 3 whole square minus 1, that is equal to 3 into 4 by 3 minus 1, which is equal to 4 minus 1, which is equal to 3. But 3 is not equal to 0. So f of 2 by root 3 is not equal to 0. So 2 by root 3 is not a 0 of the polynomial. So it is a no. So for first value it is a yes, but for second value it is a no. 8th bit, f of x equal to 2x minus 1, x equal to 1 by 2, comma x equal to minus 1 by 2. So again they have given two values. We have to calculate separately the values for 1 by 2 and minus 1 by 2. So f of x equal to 2x minus 1, f of 1 by 2 equal to 2 into 1 by 2 minus 1. So 1 minus 1 equal to 0. So as f of 1 by 2 is 0, 1 by 2 is a 0 of the polynomial. So it is a yes. F of x equal to 2x minus 1, f of minus 1 by 2, second value. So that is equal to 2 into minus 1 by 2 minus 1, 2 cancelled, minus 1 equal to minus 2, but this is not equal to 0. So f of minus 1 by 2 is not equal to 0. So minus 1 by 2 is not a 0 of the polynomial. So it is a no. Like, share and subscribe for more interesting maths videos on polynomials and factorization.